In our previous lecture, we had discussed about sort set, then properties of sort set, different operations on sort set, and sort matrices, and properties of sort matrices like union, intersection, complement, restricted union, restricted intersection, and after that we had discussed about hypersoft set. So Hypersoft set was developed by Florentin. So in our previous lecture, we had discussed about Hypersoft set, then crisp Hypersoft set, fuzzy Hypersoft set, then intuitionistic fuzzy Hypersoft set. After that, futurosophic Hypersoft set. So here there is a paper, an inclusive study on the fundamentals of Hypersoft set. So after definition by Florentin, we will discuss some operations like here is discuss Smarandache developed hypersoft set theory as an extension of soft set theory. So first of all, hypersoft set are extension of soft set theory to educate the existence. So here in this study, essential elementary properties like knot set, subset, absolute set, and aggregation operations, union, intersection, complement, and or restricted union, extended intersection, relative complement, restricted difference, restricted symmetric difference. We will discuss all of these properties or operations on hypersoft set. In our previous lectures, we have discussed these operations for soft set. Here we will discuss about these operations and properties for hypersoft sets. So here keywords in this uh, paper will be hypersoft set, hypersoft relation, hypersoft function, hypersoft matrices. There is introduction. In introduction, he says that first of all, there was soft set theory developed and properties like union intersection operations. After that, restricted union, restricted intersection was developed. After that, knot set, then soft matrices were developed and De Morgan laws were verified. After that, in 2018, Smarandache introduced the concept of hypersoft set as a generalization of soft set. If you want to see about this paper of Smarandache in 2018, we had discussed this paper with complete detail and complete discussion in our previous lecture with the help of examples. So what is in this paper? In this paper, some essential fundamentals like elementary properties, set theoretic operations, basic laws, set relations, set functions, and matrix representations are uh, discussed. So here we will start our lecture with basic definitions like we had discussed about definition of soft set. So you can see the definition of soft set from our previous lecture or uh, from a paper which is titled as fundamentals of soft set theory. If I write here the title of the, you can see fundamentals of soft set theory. Here you can see the definitions related to the simple definition, or here is a definition of subset, but this is written in some complex notations. So in this paper you can see complete definition of subset with the help of basic and very easy examples with properties and fundamental operations. So here is the definition of soft subset. You can also see this definition from this mentioned paper, fundamentals of soft set theory. So you can also see the definition sort subset. Here is the union of subset. You can also see the definition with example. This paper explain all these topics very well and very easy with the help of examples. So next we will discuss intersection of subset. You can also see the intersection of subset. Then the definition is hyper subset. If I share or search about Google Scholar, then here if I search fundamentals of subset theory, then fundamentals of subset theory. So this is a paper related to the study of fundamental of subset theory. In this paper, you can see first of all there is definition of subset. It's the example related to the subset. Then further there are subset definition, subset redefined, and after a definition there are examples. Then there is De Morgan laws related to the subset theory, not set. Then this is complement, relative complement, intersection, union, and operation or operation. These definitions are written in simplest form and in simple notations with the help of basic examples. Like in each topic, there are examples related to the topic. You can see fundamentals of subset from here. So after that, you can also see next definition is Hypersoft set. So definition of Hypersoft set, we had discussed this definition in our previous lecture with great details. If you will search about this definition, then this will be this is the paper where you can extension of subset to hyper subset and then to lithogenic hyper subset. We had discussed earlier this paper in great detail with the help of many examples. You can see the previous lecture for understanding of this paper. This paper was written by Florentin Samarachi, and there is the definition of the hypersoft set. Let U be the universal set, P of U will be the power set of U. Then A1 up to so on A and R attributic values attributes, and similarly related to these attribute values are A1 cross A2 A3. Similarly, the pair F A1 cross A2 cross up to so on AN is called hypersoft set. So here F from A1 cross A2 cross A3 cross AN to P of U is called hypersoft set. Then there is example related to the definition. You can see the example. So here we will come to our today's paper. Here is Hypersoft set definition and there is example. If we discuss this example, suppose that Mr. X want to buy a mobile from a mobile shop or market. There are 8 kinds of mobiles like M1 mobile, M2 mobile, M3, M4 up to so on. There are 8 mobiles, 8 kinds of mobile. So best selection may be evaluated by observing the attribute like A1 is company, A2 is camera resolution, A3 is size, A4 is RAM, and A5 is battery power. So these are five attributes. Their attribute values are B11, B12, capital B2 is equal to B21, B22, B31, B32, B41, B43, B51. These are five attribute values. Then G will be equal to B1 cross B2 cross B3 cross B4 cross B5. So here is Hypersoft set. G1 collection includes first Hypersoft set includes two mobiles which fulfill the properties G1 properties means any kinds of properties he want like B11, B21, B32, B41, B51. So only two mobiles M1 and M2 mobile have these properties. Similarly, G2 properties, you can select any properties here. So G2 properties are included in M1 mobile, M2 mobile, M3 mobile. Similarly, G3 properties are included in M2 mobile, M3 and M4 mobile. Similarly, G4, G5, G6, G7, G8, G9, G10, G11, G12, 13, 14, 15, 16. So these are some properties like G1 properties, G2, G3 up to soon G16, and these are the collection of mobiles which are included including these properties. So further definition is let f of u be the power set or collection of fuzzy subset. Then this is definition of is a fuzzy set of this is definition of fuzzy subset. So here if we discuss this by and with the help of an example, this topic is also discussed in our previous this paper. Here are three definitions like crisp hypersoft set, fuzzy hypersoft set. So what is fuzzy hypersoft set? If our selection is F tall, white, female, Italian, and there are two mobiles like M1 in our previous example and M3. M1 0.6 means M1 has these properties 60% and M3 or X3 mobile has these properties 70%. This is definition of fuzzy hypersoft set. Only fuzzy hypersoft set tells about degree of belonging. Means X1 belongs 60% and similarly X3 belongs 70%. So here is the example of fuzzy hypersoft set. We also had discussed about fuzzy hypersoft set example in our previous lecture or previous paper. So here is the another example, example number 3.2 we had discussed earlier. So here if we explain G1, G1 include two mobile M1 and M2. So here is 0.1, M1 means 10%. These G1 properties are included in mobile 1. 0.2 means 20%. These G1 properties or attributes are included in mobile number 2. After that, if there is another hypersoft set which is G2, so here are M1, M2 and M3, three mobiles having G2 properties. So mobile 1 has 10% these properties. Similarly, M2 mobile has 20% these properties. M3 mobile has 30% these properties. Similarly, G3 properties are included in three mobiles, M2 mobile, M3 and M4 mobile. So M2 mobile has 20% these properties. Similarly, M3 mobile M3 mobile has 30% these properties, and similarly M4 mobile has 40% of these properties. Similarly, you can check for another G4 attributes: G5, G6, G7, G8, G9, G10, 11, 12, 13, 14, 15, 16. So here if I discuss about G16, so what is meaning of G16? It means that uh, here are four mobiles: M4, M5, M6, M7 and M5. Five mobiles have these properties. M4 mobiles have 40% these properties, these attributes. M5 has 50% these attributes, and M6 has 60% these attributes. M7 has 70% these attributes, and similarly M8 has 80% of these attributes. So here is another definition of hypersoft subset. This is definition simple, same as uh, definition of soft set. So here are two hypersoft set, one and two hypersoft. These are notations. These are simply notations. One notation and two notation are hypersoft set. Then first one is called the hypersoft subset of second one if G1 is subset of G2, means these set are subset of each other, and for all the elements of G1, so hypersoft set of G subset will be subset of hypersoft set of G2. There is a example related to this. This is first hypersoft set, this is second hypersoft set. So you can simply check these two properties. First of all, G1 subset of G2. G1 include G1, G2, G3, and G2 include G1, G2, G3, and G4. First condition of the definition of hypersoft set is clear. Second definition will all the elements of first hypersoft set are subset of second hypersoft set. So these are definitions are completely holding. So first hypersoft set is subset of second hypersoft set. Similarly, a set G, G1 cross G2 cross G3 up to so on Gn in hypersoft set. This is hypersoft set is said to be not set if it has the representations as this is the same definition as we discussed in our this paper. Here will be definition of not set. This is definition of not soft set. This is same definition of not hypersoft set. So this will be equal to not G1, not G2, not G3, not G4. So we will write the mobiles which are not included in G. So that will become not G1, not G2, not G4 up to so not GM. Similarly, taking set G1 up to some G5 from example 3.6, example 3.2 related to the definition of not soft set. Another definition is relative null hypersoft set. A hypersoft set is on G1 is called a relative null hypersoft set with respect to G1 subset G2, G1 subset G denoted by hypersoft G1 if for all hypersoft for all element of G map on 0 or has hypersoft set 0. So simply this is definition like definition in soft set. If answer is empty or 0, so this will be called null relative null hypersoft. So there is example 3.10 consider there is example number 3.2 if for all G1 has 0 attribute, G2 has means to say that G1 attributes are included in none of the mobile. G2 attributes are included in no one of the mobile. G3 attributes are not included in any kind of mobile. So this is the explanation. So further definition of relative whole hypersurface. There is answer empty. If there is answer complete universal set, then this is called relative whole hypersurface. There is another definition, absolute whole hypersurface. If all of the attributes are included in all of the mobiles, then this is called absolute whole hypersurface. Means G1 attributes are included in universal set. Means to say that universal set include 8 mobiles. If we discuss example number 3.2, so G2 attributes are included in all of the mobile. Similarly, G3 attributes are included in all of the mobile. G4 attributes are included in all of the mobile. Similarly, all of the attributes are included in all of the mobile. Similarly, these are some properties like we had discussed in our previous section of subsets. So the complement. There is another definition of complement. So complement is same as NOT set. Assuming data from table 2, G NOT of G1 are in G1 there were 2 mobiles. So out of 2 mobiles, if we subtract or vanish these 2 mobiles from it, then remaining 6 mobiles are M3, M4, M5, M6, M7, and M8. So now G2, we know from example number 3.2, G2 elements. So not G2 elements will be elements besides those elements in G2 are called not G2 elements. Similarly, up to soon G16. The relative complement is of a hypersubset denoted by there is sign related to for hyper relative complement of Hypersoft set. So this is same as in our paper of subset relative complement. This is relative whole, relative absolute subset. These are same as in a hypersoft set and subset. Only the name and properties are changed, but the property definition is same. This is complement, this is relative complement. Both of the definitions are same and both of the examples are same, but the difference is definition of subset and another is definition of hyper subset. Here simply all both of the definition like example number 3.18 and 3.19 are same. Only we will not write not in front of G1, not in front of G2, not in front of G3, and up to so not into in front of G16. These are properties, propositions, set theoretic operations like union of hypershort set. This is intersection of hypershort set. Then AND operation of two hypershort set or operation of two hypershort set, restricted union of two hypershort sets. Similarly, restricted difference of two hypershort sets. These are examples related to the hypershort set. These are properties. We had discussed all of these properties in our previous short set theory paper. So idempotent laws, identity laws, dominant laws, properties of exclusion, property of contradiction, absorption laws, commutative laws, associative laws, De Morgan laws, distributive laws. Now, relation and function of the hyper subset. So we will discuss Cartesian product of two hyper subsets. This is the main definition here. Here in next part of this paper, there are only two topics: Cartesian product and matrix. How to form matrix by using hyper subset. So first of all, we discuss about Definition 6.1 Cartesian product of two hypersoft set. If we take two hypersoft set 1, hypersoft set 2 on G1 and G2 denoted by hypersoft set 1 cross uh, hypersoft set 2. This is the main if I write this is main definition here. Cartesian product of two hypersoft set. This product can be represented as a third hypersoft set where G3 is equal to G1 cross G2 and hypersoft set on G3 is power set from U cross U. Means to say we can write hypersoft set 3 is from G1 cross product G2. This is G1, this is G2. From G1 to G2, P of U1 universal set 1 or universal set 2 universal set Cartesian product. Means to say G1 cross G2 on U1 cross U2 power set. So further this is definition. Then we will discuss with the help of example. Here what type of element will be included because this is Cartesian product, so two kind of element. First element from G1 and second element from will be from G2. So here will be hyper source set will be hyper source set from element Gi means to say from G1 and hyper source set from element G of J from G2. For all G means to say G1 G1 G2 2 G1 3 G1 4 1 5 1 6 2 2 2 3 2 4. You can say that it depends on the value of I and J. Means to say that G1 is from G1, G2, G3, G4, G2 is G1, G2, G3, 4, 5, 6, and similarly that. So here is the definition. If first hypersoft set, second hypersoft set belongs to this, then relation from G first hypersoft set to second is set called hypersoft relation. This is definition of hypersoft relation. And this is definition of domain and further definition of range, like in our previous paper of hypersoft soft set. So further in this paper, what will be the after domain range hypersoft set relation? There are examples related to the our previous product as we discussed earlier. As G1 first hypersoft set is G1, G2, G3, and second is G4, G5, and G6. So their Cartesian product will be G1 with G4, G1 with G5, G1 with G6. Similarly, G1, G2 with three elements, G2, 3 with these three elements. So this is Cartesian product, and we can form a relation by putting any of these elements. So first element will be domain and second element will be the range of this hypersoft relation. Further, these are some properties related to the hypersoft relation. Then our main topic and last topic of this paper will be these are some example and definitions so related to domain and range. Our next and final topic will be matrix representations of hypersoft set. So matrix, our last topic from this paper representation is matrix representation of hypersoft set. So here first of all we simply write the definition. If our element belong to the relation, then our answer will be 1, and if our elements of hypersoft set does not belong to the soft hypersoft set relation, then answer will be 0. So if I form a matrix, So this is metric form. If I write the example, this is universal set U1 to U5. This is H1 to H5, where each Hi is a ith tuple for I number of the attributed values. Then H1 includes two elements U1, U2, H2, H3, H4, and H5. So here, if we want to find form the matrix, so this universal set, if I write, there are five elements, so this will become one, two, three, four, five. Elements of universal set will decide the rows in our matrix, and these attributes will decide the columns in our matrix. So first column, second column, third column, H4, fourth column, H5, fifth column. This is U1 up to shown U5. This is H1, H2, H3 up to shown H5. So remember that our elements of universal set will decide the rows of matrix, and elements of the another set means H is H1 attributed values will decide the columns of our matrix. So if we see the relation, the main relation will decide the matrix. U1 is first row and H1 is first column. So first element will be 1. Similarly, U2, H1. This is U2 second row and H1 is first element. So this will also be 1. U4, we will come on fourth row and H3 third column. So this element will also be 1. Another other elements which are not included here will be 0 by definition of uh, so Hypersoft matrix. So here U5 is fifth row and H3 is third element. So this element also be equal to 1. Similarly, U2 second row and fourth element will be 1. Similarly, U3 H4. U3 means third row and fourth element will be 1. U4 means fourth row and fourth element will be 1. Other elements will be 0. So this was our final topic related to this paper, which was Hypersoft functions or Hypersoft matrix. So here are some properties of Hypersoft matrices like union, intersection, complement, and all of these properties. You can see these properties. So this was our paper related to the Hypersoft set. Here we had discussed about many of the properties like intersection, union, complement, relative union, relative uh, intersection, complement, relative complement, absolute, null, Hypersoft, absolute set, Hypersoft, null set, Hypersoft, relative absolute set, and Hypersoft function, Hypersoft domain, Hypersoft range, Hypersoft relation, and Hypersoft matrix, and properties of Hypersoft matrix like union, intersection, complement, relative complement, and their properties. And similarly, properties idempotent law, De Morgan law, identity law. These are properties we had discussed in our paper. So next time we will discuss another paper of sort set theory. So for the next time, we will discuss with the help of examples and with the help of great preparations. So until that, goodbye, stay blessed.